This is question 1 for Oxford, what is called MAT program. Is part of the admission requirements for certain math and the related majors. For more information, you can check out the website, and the link is provided in the video description. Now, for part 1, there are 10 multiple choices problems. We're going to cover these problems in this video. All right, let's get started. Now, the first one, this is about looking for real number solutions for this equation with absolute value. Of course, noted here, absolute value is going to be equal to x if it's non-negative, otherwise negative x. So we're going to have this quadratic equation for two cases. Yeah, so the first case is when x is non-negative, the equation becomes x squared minus 3x plus 1. Of course, you can solve this equation, use quadratic formula here. It's going to be 2, that's going to 3 plus or minus, and then the determinant is going to be b squared 9 minus 4ac, it's going to be 5. Okay, you have two numbers, both are greater than 0, so that's both roots are taken. Now for the other case where x is negative, then the equation here, you're going to rewrite it as negative x squared plus 1 equal negative 3x. Move everything to the right hand side. What you get is the equation is going to be x squared minus 3x minus 1 equal to 0. Again, you can use quadratic formula. It's going to be equal to 3 plus or minus. This time it's going to be b squared minus 4ac is going to be 9 plus 4, square root of 13. Now, notice, however, this only makes sense if x is smaller than 0, and here one number is greater than 0, so you need to get rid of the positive numbers, right? So here, what we have is you only take the negative one. You can take, okay? So this is both greater than 0. This has to be less than 0. So the answer here is going to be D. Okay, question number 2. Here says 100 circles share the same center and they're named with this. And for the adjacent circle n and n plus 1, if you have a tangent line, you're going to meet at 2 points separated by a distance of 2. Let's draw a picture here. So you have a circle. Let's say this circle is Cn, and you have a bigger circle. Let's say this circle is Cn plus 1. Well, the statement saying that you're going to have a tangent point and meet at 2 points separated by 2. So in other words, if you draw a tangent line here, okay, so the distance is 2, meaning the is 1 and 1, and you just draw the triangle here. Now here is going to be r, the radius, two different radius. Let's r be rn versus rn plus 1. Now here you have this triangle here. This is a tangent line, so this is going to be a right triangle. So you can apply the Pythagorean theorem here. That is rn plus 1 squared minus rn squared is going to equal to 1. So you know that rn squared is going to be an arithmetic sequence. So that means R100, we're looking for the radius for the 100th circle is related to the first one by this arithmetic formula here, right? So here the square would equal R1 square plus 99 times the difference here is 1, right? So times 1. That R1 is given as radius 1, right? So that's whole thing is 100. So which means R100 is going to be square root of that is 10. Now this time the answer is also D. All right, move on to the third problem here. Now here we are talking about this equation here would represent a circle. Okay, so what you do is you have to complete the square here, right? All right, let's do that. So this equation here, let's rewrite it by completing the squares. So that's gonna be x minus 2k squared plus y minus 2 squared. Now here you have extra term that is 4k squared. You have extra term that is 4, but you have 8 here. So what you do here, you need to add 4k squared. And here it has 8, so you have to add 4 here. For the left hand side, right hand side is the same thing here. Okay? So for these to represent a circle, now you have x minus 2k squared, y minus 2 squared, and this whole thing moved to the right has to be a positive number. In other words, you further rewrite it, the same thing here. The right hand side is going to be k to the third minus 4k squared. Sorry, this should be minus. I made a arrow earlier. This should be minus here, and it become positive because you have plus 4k squared here, so you have to subtract it to balance it out. And when you move to the right hand side, become positive here. Okay, so minus k and minus 4. Got it? And the right hand side has to be greater than 0 in order for the equation to represent a circle. Now, here you can factor k plus 4 here, right? So what you do here is the right hand side has to be greater than 0, or k plus 4, and then factor is going to be k squared minus 1, has to be greater than 0. Okay? So if further write is k plus 4, k minus 1, and k plus 1 greater than 0. Now, for this cubic polynomial, we want the whole thing to be positive. You draw a number line, okay? And then you mark the roots here, -4, 1, -1, and 1, right? So in order for the whole thing to be positive, the rightmost one is always positive. This term here is going to be positive, 3 terms. So this is good. So this is where the whole thing is positive. All right. And when you jump, one term will change sign. This whole thing become negative. This is going to be here positive, negative, positive. So the whole thing is negative. And in this region, it's going to be positive again. So the answer in this case is B. Yeah, so either in the highlighted interval here, right? So that's the answer, all right, for problem 3. Let's look at problem D. Here we have a sequence with recurrence relation, and we try to find A10, the 10th element, where you can argue with this recurrence with the power and the coefficient. And I prefer first take some transformation of this into logarithm, make it easier. Okay, the base doesn't really matter, but here, since this is 8, maybe I use base 2 logarithm. Let's do that. So log 2 an, and using the property of the logarithms, right hand side is going to be log 8 plus 4 log an minus 1. Alright, so this becomes 3 here. Yeah, so this is actually 3. And in order to have a geometric sequence, I would like to add 1 on both sides and add 1 here. Okay, so that is, if you let 1 plus log 2 of ai equal bi, then the recurrence becomes bn equal, here you have 4 plus 4, that is 4 times 1 plus log 2 of am minus 1, so that becomes 4 of bn minus 1. So this is a geometric sequence. Maybe easier to make the argument that b10 is going to equal 4 tenth power of b0. What is b0? b0 is for 10, that's going to, by definition, 1 plus log 2 of 3. Using the property of the logarithm, so this further equal to log 2 of 6. Yeah, this is the property of logarithm, right? And then if you time something, is equivalent to put this to the power. So that's going to be raised to 4 to the 10th power. Okay, so this whole thing is a logarithm here. Okay, what is the left hand side? b10. What's b10? b10 here is, by definition, is equal 1 plus base 2, this is b10 of a10. So that is, in other words, is log 2 of 2 times a10. Yes, left hand side equal right hand side. Earlier we said that is 6 4 to the 10th power. Yeah. So what is a10 here? These two equal to each other, right? So a10 is going to be 1/2 of 6 raised to 4 to the 10th power. Okay, so look at the solution here is going to be, let me see, 6 2 to the 20th power, 6. Okay, so that's equal. So it's going to be E is the solution. Okay, so you can work directly with original recurrence, and you don't have to take the logarithm here. But personally, I think logarithm make it easier to justify. Okay, so let's move on. Question E. Now here for this expression, we would like to find out like terms are going to be collected together. One term that is independent of x, that is constant term, and the value of this term. So for this expansion here, you notice that x and 1 over x would cancel. In order to have a constant term, the power of x and 1 over x had to be the same. So there are three cases. One is where you have 1 to the 4th, and then both x and 1 over x have 0th power, yeah? Or 1 to the 2nd, where x and 1 over x just 1's power, or 1 to the 0th power, but then x and 1 over x both have square, yeah? So three cases. In the first case, that's gonna be just 1. In this case, the coefficient is going to be, for choose 2, n times to choose 1. In this case, it's gonna be for choose 2. Okay, so the coefficient, you're gonna add them together. So that's the first one is 6 times 2 is 12, and that is 6. So the total is going to be 1 plus 12 plus 6, that's 19. Okay, so that's the answer. Move on. Okay, here we're given that 5 theta sine has this formula here, and we try to find sine 72 degrees. Okay, so notice that 72 times 5 would be times 5, that's 360, and the sine of that is 0. So just plug in to this equation here. What we get is, we get 0 equal, for simple notation, let's assume sine 72 degree equal x. We need to find x. Plug in the formula here, 5x minus 20x to the third plus 16x to the fifth. Notice that we know for sure this is going to be a positive number, right? So x is not equal to 0, so you can get rid of x here. That becomes, equation becomes 16 x to the fourth minus 20x squared and plus 5 equals 0. Of course, you take x squared as a root and plug in the quadratic formula here. So x squared is going to be 32, 20 plus minus square root of b squared 400 minus 4sc. Okay, so that's going to be square root of 80. That's 20 plus or minus 80 is going to be 4 square root of 5 divided by 32. What do we get? We get x squared equal, so cancel 4, you have 8, and you have 5 plus minus square root of 5. Notice that we know for sure sine 72 degree is going to be greater because sine in the first quadrant is increasing from 0 to 1/2 to something bigger than 1/2. So this is definitely bigger than sine 30 degrees. So not only x is greater than 0, x is also greater than sine 60 degrees is going to be square root of 3 over 2, and x squared would be greater than 3/4. So in this case, we know for sure x squared has to be the positive sign, yeah? Because for the negative sign here, 5 minus negative square root of 5, the whole thing would be too small. We need the whole thing is bigger than that. So at the end, what is x sine 72 degrees is going to be square root of that, right? 5 plus square root of 5 over 8. So the answer here is going to B, A. That's the answer. Okay. So let's look at this problem here. This is actually a very famous expression here in a lot of number theory class, probably at the college level, not necessarily on the high school level. And we have this, factor, and we want to say plus 4. Okay, this is plus 1. Okay, so plus 4. I don't know how this is related. Here we try to argue, is this a prime or not? Is it never a prime, or a prime for exactly 1 or 2, or prime for 3 or 4 numbers, right? And I don't know why they're putting this. This may not be relevant, okay? But this is a very famous example. So the way to factor that is not to use square root of 2, rather we're gonna do this, okay? That's a trick. May not be obvious, but fourth power plus 4 is actually equal, I'm gonna minus 4n squared and plus 4n squared, okay? So what do you have here? You want to complete the square here, right? So these two terms cancels, right? So we add these two terms, and then for n to the fourth power, and this you want to do the complete the square. So n squared plus 2, you want to square it, right? So here what you get? You get n to the fourth plus 4n squared and plus 4, right? These three terms here is completing the square. And then you have 2n squared, okay? So what do you get? You get n squared plus 2m plus 2 and n squared minus 2m plus 2, okay? So that becomes, in the first term, it's m plus 1 squared plus 1. The second term is going to be m minus 1 squared plus 1. Yeah? So it says for whole number, for positive, n is positive. So n is positive, this is going to be greater than 2. Okay? So n is, let's say, 1, right? So this is going to be, but here it could be 1, right? So when n equal to 1, this becomes 5. Now, when n greater than 1, notice that here the first number is greater than 2. The second number is also greater than 2, right? Because when n equal to 2, that's equal to, and when n is bigger, this is bigger. So this is going to be composite. So this is almost composite except for n equal to 1. So the answer here is a prime number for exactly one positive number. Okay, so that's here. All right. So if you pay attention to the given equation here, I don't know how that would help you. Let me think about it. Maybe this just try to give you a hint that you try to factor this term here, right? But again, this is actually a well-known problem. Personally, I have seen this problem before, so if you have not, it may not be obvious you want to complete the square like that, okay? Try to factor. But again, maybe this is a clue for you, okay? How to factor the equation here, all right? Let's move on to the next problem here. We have equation with log base 2. And the right-hand side, of course, we want to rewrite it with log base 2 here, using the property of logarithm. So the right-hand side can be rewritten as the 3 move to the power here. And plus 1 is equivalent to times 2 here, base 2 of the whole thing, and equal the left-hand side, right? So it's going to be, I'm going to skip that. So in order for the equation to hold, what you get here, this whole block here has to equal this part. So the equation becomes 2x to the third 7x squared plus 2x plus 3 equal, here you can expand this out, yeah, so it's become 2x to the third plus 3x squared times 2, that will be 6x squared plus 6x plus 2, okay, and this term would cancel, and then become a quadratic equation here, that is x squared minus 4x plus 1 equal to 0. Completing the square, x minus 2 squared, and plus 1 minus 3, so equals 3. So x will equal 2 plus or minus square root of 3. Notice that for logarithm to make sense, x plus 1 has to be a positive number, and this has to be positive. I believe in both cases, this is positive. Okay, so both x would be valid, so the answer is C. Okay, let's move on. So each have 5 fair coins, none with head and tails with equal probability. And there are 2 events. If Alice wins, strictly more heads, and or if they have the same number, we call it draw, with P2. For the other case, which I mentioned, that is, if Alice loses, by the symmetric property, that's going to equal to P1. So in other words, we have 2P1 plus P2 would equal to 1. Okay, why is it 2P1? Because symmetric property with the same probability that Alice would lose. Okay. Now the key here is to find out what is the correct value for P2. P2 means what? Okay. So P2 is equal, the Alice has a 0 head and Bob has 0 head, or have 1 head, both have 1 head, both have 2, or both have 5 heads, right? So that's going to be the summation. Let's I count the number of heads for both people here. It could be 0 to 5, and the probability that Alice, the count equal I, with this probability, times the probability that Bob, the head, also equal I. Yeah. So in the case where, since the coin's fair, with 5 total 5 coins, right? The probability that are equal to I would be 5 choose I times 1 over 2 to the 5th power. Yeah. So in the other case, for the Bob, same thing. So you need to square that. Okay, so you need to have this one, this become 10th power. Okay, and the sigma is going to be from I to 0 to 5. Okay, so that's equal, this is a constant here, yeah, so we have constant which is 1 over 20, and here is going to be the square of the coefficient for the binomial coefficient for the 5i, right? So it's 1 square plus 5 square plus 10 square and plus, this one is going to be, so let's write it here, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Okay, so plus 5 square plus 1 square. Okay, so that's equal, so not 20, this is 2 to the 10th power. It's not 20, okay? That's 2 to the 10th power, okay? So here is this summation here, yeah, is 26, 126, okay, times 2, and there's 2 to the 10th power is 10, 0 to 4, right? So divide by 4 on both top and bottom, that's gonna be 256, and here is gonna be 63. Okay, so the answer is A. Okay, that's the problem 9. Okay, the final problem in the question 1. Okay, here we say that the real number m and c says that this equation has repeated root, and also the other equation has repeated x. Now he says, with that, how about the straight line mx plus c? Okay, so you may be tempted to expand this out and use the quadratic determinant to say that, m and c has to satisfy the certain condition for this equation to have just one root, right? But there's an easier way of doing this problem. And the problem most students might tempted to do is to expand this out. What you get is x squared plus m squared x squared plus 2mxc plus c squared equal to 1, right? And then argue that, oh, this is a quadratic equation, and try to calculate the delta equal b squared minus 4ac has to equal to 0. Yeah, but that is not the way to go in this case. Why? Because you need to pay attention. This one and this term here. So what is it? If I rephrase this, okay, to a different problem, you may realize there's an easier way of solving this problem. Okay, let's do that. So let's assume I rewrite this to be a equation x squared plus y squared equal to 1. And we write the second one is x minus 3 squared plus y minus 1 squared equal to 1. So forget about what they're saying here. Forget it. Now I give you a new problem here. I have two equations here. You immediately know that they represent two circles. Okay, so two circles. Okay, let me erase this. It's a unit circle here, right? It's a unit circle here. Okay, and the other one is same circle radius but different position, x equal to 3, the 3 and y equal 1, somewhere there, right? So if I tell you I have a 9 here, I have two circles, I have a straight line here, okay? Let's say straight line is over y equal mx plus c is a straight line, right? So I draw a straight line, use different color. Okay. If I tell you, how do you find the intersection point here? What do? You plug in this into the equation, both, yeah, and you're gonna find it, yeah. So usually there are two solutions, yeah, because this is just a plug-in, right? Plug in y here. But we're saying that they only have repeated rules, one solution. Of course, you know that could happen only if the 9 is tangent, right? Okay. So what we're saying is, how many possible way for this 9 in order to be tangent to both circles? Of course, you can see there are 4 different ways, right? One is here. The other one is over there, yeah? And you can also have tangent line like that, right? Go to this direction here. Or you can have yet another orientation where the 9 would be tangent to both circles. So the answer to the problem is, how many possible? There are 4 different ways, okay? Let's erase that. So the answer is E. Okay, so that's the answer here. Let's use a different color here. So that's the answer. Okay, so it's really important to not to use this approach, rather to realize that this is actually a different problem, is hidden in a different way of presenting this problem to you. But in your mind, you should think of this as two circles and try to find the intersection of straight line and circles, and repeated rules meaning the line happens to be tangent to the circle, or in this case, tangent to both circles. Okay, so that's it for the question 1 of the MAT exam, and we're going to cover the rest in separate videos. Thank you for your time, and please subscribe to the channel.